Now let us have a look at shift microoperations. What is there are three types of shift microoperations that can be performed, three categories. One is the logical shift, another the circular shift, and the third is arithmetic shift. And shift can be of two types, whether the binary number, the bits in the number can be shifted to the left or to the right. So in each category there will be two subcategories, either a left shift or a right shift. Let us have a look at them one by one. So if I have a logic to do a logical shift, which sometimes is also denoted by just the word shift. So if I say shift, it generally means logical shift. Okay, in the logical shift, there will be logical shift left and logical shift right. So let us take an example. Say I have a number, binary number 1010. If I have to do a logical shift left, so each bit is to be shifted by one position to the left. So this 0 will go to this position, this 1 will go to this position, and this 0 will go to this position, right? And this 1 will be overwritten by the 0. So it will become 0 1 0, and this position will now become empty, right? So in this position we had to insert something. So if this is a logical shift, here we insert 0. At this place we will insert 0. So all the bits are shifted in this number to the left, and then the least significant bit is filled with 0. In the logical shift right, we do the same thing but in the opposite direction, that all the bits are shifted towards right. When we shift all these bits towards right, so 1 will come here, 0 will go here, and this 1 will go here, and the first this highermost bit, this position will be filled by 0, because this is logical shift. The second is circular shift. So the shifting is done in a circular way, that if I have to do a circular shift left of these bits, I will shift them towards left. So this 1 will go out, this 0 will come at this place, this 1 will come at this place, and this 0 will come at this place, fine. And this least significant bit will be filled by the most significant bit in the previous one. That is the bit which got out, which was pushed out. So this is a circular way, fine. So all the bits are to be shifted left, and the most significant bit becomes the least significant bit, like a circle. So when that is done, it will become 0 1 0 1. And if I do a circular shift right, so these bits are to be pushed towards right. When I push them towards right, so 1 will come here, 0 will come here, this 1 will come here, and this 0 will in a circular way reach here, this position. So it will become 0 1 0 1. The third category is arithmetic shift. Arithmetic shift is done on numbers which have a sign bit also there, signed numbers. So if I have to do arithmetic shift left, say I have a number 1010. Since this is a signed number, that means this 1 is the sign bit, and the magnitude is represented by these three bits. So let me separate them. So this 1 is the magnitude, this is the sign bit, implying that this number is a negative number. And what is the magnitude? It is this 0 1 0 0 1 0. And so this is 2. This is decimal 2. So this number is actually minus 2 in signed magnitude representation. Now let us do the left shift. When we do the shifting, I will not touch the sign bit. I have to do the shifting of these bits. These bits can be shifted in a way we do shifting. So if I have to shift this left, what will happen? This 1 will go here and this 0 will go here. So this 1 is here, this 0 is here, and the least significant bit is empty. There we will introduce 0. Right? The empty space is filled with 0 here also. So we get this number 1100. Again, this first bit is sign bit and the remaining part is the number. And if we look at this number, what is this? This is minus and 100. This is 4. So from this, and also we should remember this, that whenever we do arithmetic shift left, the number is multiplied by 2. So this was minus 2. This becomes minus 4 by arithmetic shift left. Let us see arithmetic shift right. So let us say the number is 1010. 1 is the sign bit and the magnitude is 010. Shift the bits to the right. So 01 will go to here and an empty place is here. This will be filled with 0. So the answer will be 1001. And again, if we look at the number, the given number was minus 2 and the answer is minus 1. So this means that the arithmetic shift right operation divides the signed number by 2. So this divides the number by 2. This multiplies the number by 2. So these are the various categories of shift microoperations. They can be symbolically represented like this. So the first is the logical shift left, which can also be called shift left. So the second is logical shift right. So this is the way, this is the symbolic designation of these microoperations. So SHL means logical shift left, SHR logical shift right. This is circular shift and this is arithmetic shift. Now let us create a circuit that performs this shifting operation. So this is a circuit in front of you. This very simple circuit will perform the shift microoperation. And this circuit is meant for 4-bit number. So let us say the number is this 4-bit, A0, A1, A2 and A3, fine. And whenever I shift something to the left, if the number is shifted to the left, there will be an empty place at the first position. So that empty place will be filled by this input, which we call as serial input. And if the number is shifted to the right, on the left hand side, there will be an empty place, the most significant bit place, that will be filled by serial input IR. Fine. So it depends on what type of shift is going on. If it is a logical shift, obviously this and this will be 0. And for creating a 4-bit shifter, we need 4 multiplexers. For creating an 8-bit shifter, we need 8 multiplexers. And each multiplexer will be 2 cross 1. So each one is, it is a 2 cross 1 multiplexer. That is, it will have 2 inputs and 1 output. Fine. And since each multiplexer has 2 inputs, it must have one select line, and which will decide which of the 2 inputs will go to the output. If the select line is 0, this will be the output, this line. And if the selection line is 1, this second line will be the output. This is what multiplexer does. Now what will we do? Instead of taking them directly, A3 here, A2 here, A1 here and A0 here, no, we will do the shifting way. we know that if the select input is 0, we want a right shift. So if there is a right shift, so all the bits should be shifted toward right. So A3 should go here, A2 should go here, and A1 should go here, and A1 should not go anywhere. When this is 0, that means A3 should go to this place, 0th place, A2 will go to this, and A1 will go to this place. So this right shift can be easily done. We just have to put the select line as 0, and we will get this bit go here, this will A2 here, A1 here, and this empty space, this will be filled by a serial input. Done. And if this is 1, if the select input is 1, then there will be a left shift. So in the left shift, what should happen? A3 should not go anywhere, A2 should go here, this is it, A1 should go here, and A0 should go here, and the least significant bit should be filled by the serial input L. So if we look keenly at this diagram, this is a very simple way of doing this shifting. And we can again use another multiplexer for this serial input, multiplexers for these serial inputs, for producing these serial inputs, and that multiplexer will decide which shift I have to do, whether a circular shift or a logical or some other shift. So if there will be a logical shift, these two will be 0. If there is a circular shift, the bit that goes out is put here. Fine. So this way we can control this which type of shifting we want to perform by another multiplexer.